While I did not intend to make this a two-video presentation, I had a little bit of technical difficulty. I lost power and my camera turned off, so this is a two-part video. So the first video talked about how their history of cellulosics and how cellulose acetate is made, and from here I will talk about properties and applications. So when you're talking about cellulosic properties, the color of a cellulose acetate can range anywhere from transparent to translucent to opaque. You can also make mottled and pearlescent type cellulosics. Ethyl cellulose produces a light amber, and cellulose acetate butyrate, and cellulose propionate are available as clear resins. This can be in both a liquid form for casting and a powder form for molding. Cellulosics has the properties of the ability to be transparent, it has the ability to have a really deep gloss, and it produces something of a natural feel. So it reminds people often of horn or things like that. So it has inherent mold and mildew resistance, it is tough, it is biodegradable, and you can process it via injection molding and extrusion, as well as some traditional methods. Cellulose acetate applications, the main one is fibers and textiles. Cellulose acetate is very dyeable, it's comfortable and breathable. It is not cotton, but it is similarly breathable like cotton. It has absorbency and softness, and it's environmentally friendly. This is often used in high absorbency products, which is also known as diapers, personal hygiene items, wound dressing, and absorbent cloth and wipes. It's used extensively in apparel and home furnishings, in textiles. It's also used as cigarette filter media. The resins themselves, when they're not used for textiles, they have a nice natural feel, so they're often used for eyeglass frames or spectacle frames. They're also used for more high-end tool handles, combs, pen barrels on higher-end pens, and the original Lego material was made out of cellulose acetate. Currently, Legos are made out of ABS, but Lego has announced that they want to move to a more environmentally friendly or sustainable resin, so they may actually be going back to cellulose acetate, but as of now they have not. It is currently ABS, being the Lego material. Cellulose acetate is extensively used for spectacle frames. I am currently wearing a pair of cellulose acetate spectacle frames that are made by the old method. There is steep competition from other thermoplastics for cellulose acetate frames. However, when it comes to a certain look in a cellulose acetate frame, you can't get it really through any other type of material or manufacturing process. The old method, they would stamp the frames themselves out of a cellulose acetate sheet and then heat that sheet by forcing wires into the softened cellulose acetate. And that method is still used. Many frames are made by other thermoplastics and cellulose acetate by injection molding. Injection molding is a lot more cost-effective than the old method, but you can't get certain color effects by injection molding that you can get from the old method, which is why the old method is still extensively used. Typically, the frames that you get that are made by the old method that have those interesting color effects cost more because the manufacturing process is more expensive. Cellulose ether is also made. This has a different structure, so shown here are your cellulose units. So instead of the protons, you would have these R groups that have an ether linkage present in them. This is also known as hydroxymethylcellulose. These are used for dispersants in suspension polymerization for vinyl-type monomers. Monomer itself is dispersed in small droplets, and the cellulose ether forms a protective film at the interface between the monomer droplets and the solvent. And that keeps the droplets from coalescing. When you heat up the final product, the cellulose ether dehydrates, and the gel that it leaves behind further strengthens the polymer that you've made from that suspension polymerization. When you make these surfactants, they give you good particle size control, good uniform particle size distribution, and porosity, which are all necessary for suspension and emulsion type polymerization. Thus concludes my very short second video for cellulosics. Again, I apologize for making two videos, but my technical problems necessitated it. This is the final video for thermoplastic resins, so I thank you for your attention to this video and the attention to the videos throughout the semester. The only thing that follows this is the final exam.